what is the time response of an undamped second order control system to a unit step signal as the input? Well, my name is Rishi Remju and welcome to the Backbench Engineering Community, where I make engineering easy for you. So let us ask ourselves that obvious question: what do you actually mean by the term the time response of an undamped second order control system to a unit step input? Well, let's find out. So we know for a fact that in the case of a second order control system, the transfer function is given as T of S is equal to C of S divided by R of S, which is equal to omega n squared divided by S squared plus 2 zeta omega n S plus omega n squared. So here now, this particular second order control system is said to be an undamped control system if the value of zeta becomes 0. So here the value of zeta is equal to 0. So now upon substituting the value of zeta is equal to 0 in this particular equation, we would now get the transfer function T of S is equal to C of S divided by R of S, which is equal to omega n squared divided by S squared plus, here when zeta is equal to 0, this term becomes 0. So therefore S squared plus 0 plus omega n squared. So let us now take this as equation number 1. So now here the time response of this particular control system is simply the time domain value of this C of S. So therefore, in order to find the time domain value of this C of S, we would give certain input to this particular control system. So here we are giving a unit step signal as the input over here. So now when we give a unit step signal is denoted as U of t is equal to 1 for t greater than or equal to 0. So therefore here R of S is given as the Laplace transform of this particular U of t. So therefore this is the Laplace transform of 1. So therefore R of S becomes R of S is equal to the Laplace transform of 1 is given as 1 by S. So now upon substituting this onto equation number 1, we would now get C of S is equal to R of S multiplied by omega n squared divided by S squared plus omega n squared. But here R of S is given as 1 by S. So this could be written as 1 by S multiplied by omega n squared divided by S squared plus omega n squared. So now in order to find the time response of this particular system, we have to now find the time domain value of this C of S. So therefore for that we have to now find the inverse Laplace transform of this particular value. So for that, in order to find the inverse Laplace transform, here we have to split this into two partial fractions. So therefore here 1 by S into omega n squared divided by S squared plus omega n squared would become, here by using the principle of partial fractions, here first this would become A by S for this term plus, here because we have S squared plus omega n squared, the numerator must be written as BS plus C divided by S squared plus omega n squared. So now let us take the LCM over here. Upon taking the LCM, we would get 1 by S multiplied by omega n squared divided by S squared plus omega n squared would become, this is upon taking the LCM, we would get S into S squared plus omega n squared here upon taking the LCM. So now after taking the LCM here, this would become A S squared plus A omega n squared plus, here upon taking this S over here, we would get B S squared plus CS. So therefore now from here we would get three equations. First, upon equating the constant terms, here the constant is A omega n squared and here the constant is omega n squared. So A omega n squared is equal to omega n squared. So therefore from this we would get the value of A is equal to 1. So next, upon equating the coefficient of S, here we have CS. But on this side, we do not have any term in terms of S. So therefore, we would get CS is equal to 0, implying that the value of C is equal to 0. And finally, upon equating the coefficients of s squared, here we would get as squared plus bs squared is equal to, here we do not have any s squared terms, this becomes 0. So therefore we get a plus b is equal to 0. But the value of a is obtained as 1. So therefore the value of b becomes minus 1. So therefore now we have the value of a, b and c. So substituting these three values onto this particular equation, we would now get this particular partial fraction as c of s is equal to 1 divided by s plus bs plus c. So here b is minus 1 and c is equal to 0. So therefore this becomes minus s divided by s square plus omega n square. Because here b is equal to minus 1, so substituting minus 1 over here, we would get s minus s, and here c is 0, so this becomes minus s divided by s square plus omega n square. And finally now, in order to get the time response, all we have to do is find the inverse Laplace transform here. So c of t is given as, the inverse Laplace transform of 1 by s is given as 1. Because here the Laplace transform of 1 was 1 by s. So here the inverse Laplace transform of 1 by s is 1. And now here we know for a fact that the Laplace transform of cos omega t is given as s divided by s square plus omega n square. So here we have this term over here. So therefore the inverse Laplace transform of this would be equal to cos omega t. So therefore this would become minus cos omega n t. So this thus is the required time response of an undamped second order control system to a unit step input. Very simple, guys, very simple. So this thus is simply what you refer to as the time response of an undamped second order control system to a unit step input. As simple as that. So I hope you guys now have a clear understanding of what you refer to as the time response of an undamped second order control system to a unit step input. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you guys in the next video. Thank you.